Next, I would like to introduce one of my good friends, Professor Shang Chiou. Shang Chiou is one of the members in Taiwan. We work together for we call University Social Responsibility Project. We are work together, and we also visit Europe to see how this is work in the world. Professor Chiou is get his PhD from the Carnegie Mellon University in Pittsburgh, USA. He is also a famous architect in the Pennsylvania, USA, and he worked for many projects in the bamboo. Actually, I just visited one of his project, which he worked with and his student to build a bamboo construction in the outside my university. We call Zhuqi railway stations. Let us take the chance to welcome for the Dr. Chiou for his speech. That's for you, Dr. Chiou.
Thank you. Let me share my file first. Okay. Do you see it on the screen?
Yes, we can see it.
Okay, so let me get started. First of all, I like to say the project Kevin sharing is so exciting. It reminds me my day when I work as an intern architect in Pennsylvania, attending this Habitat for Humanities project. Okay, so without further ado, allow me also to share my project here. Okay, so I'll just get started here. Thanks everyone to be here, and I'm glad to share the story of an artistic creation of an.
Dr. Chiou, do you want to enlarge your screen?
Okay, let me try it again. Okay, do you see the full screen now? All right.
Yes.
All right. Okay, so let me get started again. So this is an artistic creation of an bamboo installation project, and the name is Floating Cloud, and the title we call it, okay, the Floating Cloud, which we consider is modern interpretations of Taiwan's vernacular bamboo assembly techniques. Okay, so the presentation will be in the following order. First, we are talking about the floating cloud in exhibition, and then design concept, and then what we learned from the past, and then the construction and installation process, and also our search for the design freedom with this kind of construction systems. The floating cloud is one of the 6 student-built bamboo installations commissioned by the Taiwan Bamboo Society. And luckily, this project won the Golden Award for the invite-only competition. It is currently in exhibition in the Zhuqi train station, as Dr. Huang just mentioned. And these are the 6 projects being it's in the exhibition, and our project is right in the middle. And in the night, the floating cloud, we wanted to make it a temporary shelter for the cross-country traveler, or we call that Daluhan. It's a Bunong tribe's term of the hunter's hut. And we thought the warm lights from the interior invited the traveler for a cozy stay. And in the daytime, it is an outdoor furniture, or we could call that a big bamboo toys, if you may, that provides all kinds of human art piece interactions, while the metal nuts shimmering under the blue sky. And so we could see some of our design interactions. One is in the pattern. You could use like this balance one, and you can standing on top and to find a balance point. And the other pass we can do is on the right hand side. That it is actually a chair. You can sit at the at the end of this structure, and also you can climb up. And also we use the metal nuts. Actually, that is the scaffolding clamps as the reflecting dots to show the weather conditions in a way. And also, this is some of the photo we taken on site during the inauguration ceremony. And I'm especially proud of my students and colleagues in this project that they were not discouraged facing the outbreak of the COVID-19 and pandemic in Taiwan. And really, this is some challenge for us. The project begins when everything was fine. And then all of a sudden, there's a major outbreak. So all this design procedure or even the things we are not allowed to go outside, and eventually we able to overcome all these challenges. So I think it is so much more rewarding to enjoy these fruits of our dedication under such hardship. Okay, so let's talk a bit about the design concept. In the very beginning, we have decided to make this project with two purpose, two folds. The first of all, we wanted to express our appreciation of place. The place that the exhibition take place is in the Ali Mountain, all right? And then secondary, we also wanted to develop a craft systems which can be widely applied in real-world projects by everyday people. So we hope that it's beautiful outside, but it's fun inside. And let me begin with the artistic side, the expression of space. And there are plenty of bamboo forests in Ali Mountain. And so the bamboo is tall, bamboo is hollow, and bamboo is soft. And so through bending the fibers on the perimeter of the bamboo cones is actually stressed and sustain its strength. And then the space under the bamboo forest is a manifesto of the biomaterials personality, if we may, right? It folded and then we got this kind of a Gaussian church-shaped space. So this is the foremost form shaping concept. We take it with our own bamboo work. And then the mass of the mountaintop of Ali Mountain is usually floating above the cloud. So it's also a common thing there. And so it is contribute to the massing of our bamboo design. We're trying to create somehow this something floating, a mass floating in the sky. Uh, Nature-wise, the emperor peasant Dizhi, all right, that is the national bird of Taiwan, is a common residence in Ali Mountains. And so the white strips and the dots on its body as well as on its tails and wings is a very important sign that how people identify that they see the emperor peasant from a distance. So this is the same visual patterns that we wanted to carry with our floating clouds. Also, another indigenous species of Ali Mountain is this freshwater fish. We call that Taiwan Sojiao carp, kuhua. All right. When the school of fishes feeds on the rock mounds, their body turns sideways, and then the sun shines through the water, and then they just like you see this shimmering under the sun, people are on top of the water. And again, this will serve as our image that we wanted to carry. And finally, the and finally, uh, to deal with the steep slope, the path of Ali Mountain Railway is arranged in a zigzag formation. And we further expanded the metal strip pattern to pay our tribute to this 100 years old mountain railway system, the only one in Taiwan. And this tribute also pay our homage to this beautiful landscape. So let me turn to the craft sites. Starting with this picture, a not so successful exercise of both and Thai traditional joint method. This was a project exercise done by my students. We know traditional architecture as well as bamboo crafts in Taiwan use a lot of this bolting method using bamboo sticks or use tie to fasten the structure. And then through students' practice, we understand both crafts require highly skilled craftsmen to do that. It's not like everyday people can do that en masse. And then with that basic understanding, we come back to the to think about the working properties of bamboo. The bamboo, in a way, there are, how do I put it? Bamboo, in a way, when we think about bamboo, we first think about steel pipe. There are similarities and differences between them. And the similarity are this above. They are both lightweight, they have very high strength to weight ratio, and they have high mass efficiency because all the mass are on the perimeter, which either be a tensile member or compression member play that role. And then it has very long effective working length. And in Taiwan, 4 meter per piece of bamboo, which is about a similar dimension, is quite easy to get. And for steel pipe here, our standard length is about 6 meters. But there are also significant differences between bamboo and the steel pipe. The bamboo tend to decay over time because it's a biomaterial. And then the dimension actually decrease over the length. For the button who close the root is actually wider, and then gradually you become thinner. And it has lower density. So if we're talking about the weight to strength ratio, bamboo and steel pipe are similar, but when you consider the dimension, because of the low density, the bamboo actually is much weaker. And the comb is made of nodes and internodes. So it's not a homogeneous structural member like pipe. So that we need to take into consideration. And because of its low density, it's highly bendable. It is highly bendable, and so and then also it's made of fiber, not kind of composition of fiber laying together rather than homogeneous atoms. So and then also it has lower shear strength. So whenever you have penetration through the side, it very tend to split with the drilling and then split through, creating the crack. And on the right hand side is the bamboo we are using. It's again an indigenous species, and it's also the kind of bamboo that Japan's kendo use for their fighting sticks, and makino bamboo. And it is a common construction material for traditional Taiwan's bamboo house, using as roof rack. And in the nature, its diameter range from 2 to 10 centimeter, but mostly based on our observation, is somewhere between 5 to 8 centimeter. And the pole or the could be up to a 16 meter at all. But of course, the useful size, the useful length uh, in our estimation is more or less around 4 meters. And then the internode, between nodes to node, somehow vary from 10 to 24 centimeter, but it's again more close to the 20 centimeter. And the specs we use for our this 6 centimeter diameter in average is chosen. And we also use a fire roast. on the left-hand side is like 10 centimeter away from what we want to do, then we need to kind of untighten everything and then do that all together. And then in a very complicated or complex project, this will become almost impossible. And the second common method is this bowl through. And this example, they use metal bowls, but traditionally they use chopsticks kind of things to penetrate. And that created a point stress. And when we have point stress, and then without, even though if you have any outside force just to knock on the bowl and give it extra stress, the split will occur. So this is an example of how split occur. But once the split occur, they no longer able to hold it together, become no longer a complete piece. On the right-hand side is the more conventional way they use vice strip to tie the knots. But again, this requires a high skill set. And the other thing is that because both the bamboo and the vice strips are organic material, it will shrink over time. So the tie will become loosened. And in compensation, traditional construction method, they always put a wedge on the side. And whenever they go loosen, you should just knock on the wedge to tie up these joints. And then let's take a look at the assembly. And so on the real housing, upper left-hand side, the picture, you will see this non-coupling assembly. The knots, vine ties, vine strip knots, actually they use grip rather than penetration. So the structure can hold there for a long time. The house we survey on the upper left corner is already 80 years old, and everything's still intact, although it looks a little bit old. And then that same thing for roof rafter. They always, I mean, whenever there's a cross section or extension, the extension is on the upper left corner. That's the beam, right? This extension, and then this cross section is on the main beam of this rafter joint. They just don't work as coplanar. They always have a shift of these things. And then the second thing you notice is the low bearing post, which is the vertical posts. They don't necessarily want the most straight one. Sometimes they rather have this a little bit bended one, and as long as they are on the coplane of this low bearing plane. The reason being, we have checked with the old masters. They say sometimes the bamboo bands you will have this inner stress become more resistant to bending moment or other things. So this bending of the straight post itself also has certain characteristics that the reasoning behind why the old masters like to use that. The lower left corner, the picture is the modern scaffolding. And the scaffolding is made of pipe, steel pipe, but then use scaffolding clamps. And so again, that's non-coplanar assembly, but it allows this freedom of movement through rotation. So we learn from this and then really come up with our own development system. Is that the first is that for typical people, even for architecture students, it might not be easy that you, in each project, you make 200, 300 ties, perfect tie, or 300, 400, 200, 300 perfect line knots. So grip, grip is better than penetration, but we need to have something easier to make. So then we choose the scaffolding plan to replace the traditional knots systems. And in terms of times, it takes about 1 minute to fasten the clamp. It takes about at least five minutes to make a knot. And the other thing is that we could use this clamp to create it. One is the extension system, and the other is the rotation system. The extension, you only need to have two clamps to clamp on two posts, then that would be the vertical linear extension. And then if we want to rotate that here on the right-hand side, if we have one clamp on side, then we could rotate that. So that gives you a freedom of expression, or freedom of flow. And so once we have that understanding of what's going on, and we use that as our construction base app system. And so then let me share a bit about about the making of the floating cloud, which is actually two steps. One is the in-shop construction, and the second is the on-site installation. And I think the prefab, or we call in-shot installation, actually has its benefit because we have much better control of the quality as well as the needs. So this is our basic step. We start with the fire bending bamboo in the woodshop, which is in our university, National Taiwan University, which is about 200, 300, about 200 km away from the exhibition. And the first thing we learn is that since the bending, the purpose of bending is we need to lose the fiber, but there's a thickness in bamboo. Skin itself is actually more or less water repellent. So we find out the most important step to make it success is to make it fully soaked inside water. And what we do is that we sprinkle the water on the bamboo and then cover it with canvas overnight. And so now the bamboo itself is soaked with the water. And then we started to do this fire bending, which is on lower left corner. Fire bending is also a traditional skill set that used in our craft. And it's not so difficult. How do I put that? It's actually the craft is not so difficult once you know the key. Whenever you are overheated, you started to see these oily bubbles. I think is the white one. That means you are actually losing the fiber. And so just with very minimum the students can achieve a successful way of. And the other thing we find out is that the dried bamboo Okay, then once we have this bended bamboo, we started to try out how we are going to form, these floating cloud structures. And we try a couple form, and the one on the right is the prototype. And after the prototype had been decided, we test the strength of the structure with our body weights. So I'm standing on top of the prototype on the upper left corner. And then once we have this prototype, the second thing we do is to further force bend and lock the bamboo with the scaffolding clamp. So if you look at the picture on the bottom left corner, when the student do that, they actually someone forcefully to bend the bamboo further in the direction which already occurred further. So they have this pre-stress, and then we use the clamp. You use the scaffolding clamp to fix it, so the entire structure is actually pre-stressed, and so that bring about the rigidity that we needed for this structure. So the alignment of the scaffolding clamp is very important for the artistic expressions. And as we explained early on, we wanted to reflect the the sense of the place. So the V shape or the Z shape, speaking to the emperor pigeon, the national bird, or the railways patterns, that is very important. And these things happen coincidentally. One is for artistic creation, but the other is that whenever we want to overlap the bamboo to make its continuous curve, we do need to have two joints to make it expansion. So with these two joints and then with different kind of distribution, we can see from the left, from the middle, and then we were able to really achieve what we want to achieve in terms of its image. And then the finished size of the floating cloud is actually dimensions based on the size of the container of the cargo, but also that is the same thing about the size of the railways truck, because they are all of the same systems. And then we ship it overnight from Taipei to Jiayi, which is about 200 kilometers more or less. And then the same group of students, they bring it to the platform of the railway cargoes. Now, the final step is on-site installation. And when we move it on-site, the first thing we do is to check all the joints. Are they still grid friendly? Are they still grid friendly? So there are a testing on the bottom left, and also reinforcement to fasten all the loosened clamps. But it's really interesting, actually. In the beginning, we saw maybe 20% or 30% of the clamp going to be loose because the transportation is shaky, especially go up to the mountain. And in the end, I think we only pick up maybe 4 to 5 scaffolding clamp need to fasten out of this about 100 clamps. So really, the bending, the pre-bend of the bamboo give it a strength to hold the clamp all in together. And then in terms of artistic expression, we want it to be killed, right? So we use, again, traditional scaffolding method. We put 4 temporary poles on the side and use that as the lever and to adjust the tail angle. And then eventually we find a tail angle that we are happy with. And then also we are happy with. And I would say 2 minor steps, I think, is also worth sharing. We use the wider thread rather than metal steel tensils wire, because this wider thread has less cutting force, so that it's easy for people to work on without getting hurt. And then we put a crossbar to also edit a little bit of strength to make it very to increase the rigidity of the cross section. Okay, so after the completion of the project, we keep going on searching for design freedom, and by talking about design freedom, we are really talking about we try to find a craft system to be free from the orthogonal structure system of traditional bamboo house. As this one, it always has this orthogonal systems and roof rafter. So one case is this thing we call a dancing gate project. Is in an elementary school. We use double up bamboo post and the weight balance to achieve the structural rigidity. And the other example is the we call the Earth Triangle. It's a project for high school winter camp. Students want to study architecture to explore another form generation potential of this craft system. And I think it really proved that we can do on-site adjustment and with a very basic understanding with teamwork. It's a really an advantage for this craft system. Okay, so this concludes my presentation today. Thank you very much for listening.
Thank you for Professor Chiou for his wonderful speech. Let me more understand how the design which you are working in the outside my cities.